Hi, I'm Fidas bin Mohammed, and today I'm going to talk about gravitational lensing. The reference I'm using for this presentation is A. Abdul gravitational lensing. We know in the conventional sense that the light ray travel in a straight line. Hence, we assume that the object we see through telescope are exactly at the position it's at. So this means that the distant object obstructed by E cannot be seen by the observer from this direction. And this is not really true if we don't assume the account the gravity exerted by the massive object, which we might expect that the light ray will pan around the E and somehow reach the telescope. This phenomenon is called as gravitational lensing, a phenomenon where the light ray will pan around a massive object due to the effect of gravitational field. Somehow the illustration is like this. This was first proposed by Johannes Sonner in 1804, where he found the deflection angle around the sun is 0.84 arcsec, and somehow Einstein found almost similar value, 0.83 arcsec in 1913. And after the full discovery of general relativity, we are going to get the actual definition of this, which is phenomenon where the light ray from distant object will bend around a massive object due to the effect of curvature of space-time predicted by the general theory of relativity. And Einstein found the actual deflection angle is 1.74 arcsec. And this was proven to be between 20% in 1919 and recently between 0.02%, which means this formula is very accurate. This value is very accurate. And the significance of this idea is like Chaucer 1924 said there might be a possible perfection double star, and 18 in 1936 Einstein proposed the luminous circle of perfect alignment. Einstein and finally Fezzinski in 1937, galaxy can be used as gravitational telescope. An illustration of this is like this, like for example for the Chaucer, since the light rays will bend in two different directions, we are going to see two different images. So somehow fashion double star. And say that the image, a lot of light rays bending toward the same direction, we are going to see some kind of arc-like and ring-like image, which is what is Einstein is. And finally, since the apparent distance from the band light and the actual distance different, the apparent distance is going to cause it to be magnified, which how the galaxies, which are massive, can be used as gravitational telescope. And the equation related to this is based on this diagram. We are using a thin lens approximation, and what we are trying to find is the actual angle of the star. It is very simple if you think about it. It's just the observed angle minus by the deflected angle. And this is other formulas. And in case where the object lies behind the lens, where the actual angle is zero, we're going to get Einstein angle, which is this. This is how the Einstein ring can form. And this is the formula for magnification. Since this is important, and there are other formula, but I think this is the most important one. And during the time this was proposed, there wasn't any actual energy that can actually do this. So this was always a theoretical. It was not until 1979 that we found a double quasar, a facious double star, giant luminous arc showing galaxies, magnifying the galaxy around it. And finally, Newton ring somehow after 1988. And this was where the gravitational lensing is actually proven, and which I found pretty much interesting because it is a proven phenomenon, so which is visible for us, which means it's a good one. And the significance of this is we can map dark matters, as dark matters can act as a gravitational lens, and by distortion we can find where the dark matters are. Magnification of distant object, which means we can see galaxy and star from early universe. And microlensing, a moving massive star is going to allow us see background stars that we cannot actually normally see because they are very dim and very small, very far away from us. And finally, thank you for listening. This is some kind of bending light meme that I found on the internet. And again, my reference for this is up to gravitational sensing. And I hope this video was good for explaining gravitational sensing. Thank you.